Have you ever wondered how airplanes fly? A question that has sparked curiosity in many a mind. Imagine a colossal metallic bird weighing several tons, effortlessly defying gravity, soaring through the boundless skies. It's an awe-inspiring spectacle, isn't it? But what precisely makes this possible? It all boils down to two main principles of flight: lift and thrust. Lift, the invisible force that propels the aircraft upwards, counteracting the pull of gravity. It's the wind beneath the wings, quite literally. Then there's thrust, the propelling force that drives an airplane forward, overcoming the resistance of drag. These two forces, working in harmonious tandem, create the miracle of flight. It's not just about defying the laws of gravity, but rather using them to our advantage. It's an intriguing dance of physics and engineering, a testament to human ingenuity. Let us delve deeper into the magic of aviation, starting with the concept of lift. Lift is the force that propels an airplane upwards, defying gravity. To unravel the mystery of lift, we first need to understand something fundamental about our atmosphere: air pressure. Imagine air as a sea of invisible particles, constantly bouncing off each other and everything they encounter. This constant bombardment results in air pressure. Now, this pressure isn't the same everywhere. It varies with altitude and speed, and this variation plays a vital role in creating lift. Let's move on to the shape of an airplane's wing, known as an airfoil. Picture the cross-section of a wing, a unique shape, rounded on the top and flatter on the bottom. The design is not just for aesthetics, it serves a critical purpose. As the airplane moves forward, air particles split at the wing's leading edge. Some go above and some go below. The air particles moving over the rounded top need to travel a longer distance compared to those moving beneath the flat bottom, and this is where a chap named Bernoulli enters the scene. According to Bernoulli's principle, as the speed of a fluid, in this case air, increases, its pressure decreases. So the faster moving air over the wing results in lower pressure compared to the slower moving air beneath the wing. And voila, this pressure difference creates an upward force, which we call lift. The lift needs to be greater than the airplane's weight to get it off the ground and keep it soaring high in the sky. So every time you see an airplane cruising in the sky, remember, it's not just a marvel of engineering, it's a ballet of air particles, a symphony of pressure differences, and a testament to the principles that Daniel Bernoulli penned down centuries ago. Now that we understand lift, let's move on to the second principle of flight: thrust. Thrust is the force that propels an airplane forward. This is the powerhouse of flight, the driving force that propels our metal birds through the sky. To appreciate the principle of thrust, we need to delve into the heart of an airplane: its engine. The engine is a marvel of engineering that uses a series of steps to generate thrust. First, air is sucked into the engine, usually at the front, a process aptly named the intake. This air enters a compressor, where it gets squeezed, increasing its pressure, a bit like squeezing a balloon full of air. Next up is the combustion stage. The high-pressure air is mixed with fuel and ignited, creating a powerful explosion. The energy from this explosion drives a turbine, which in turn powers the compressor. The remaining hot gases are expelled out of the back of the engine, creating the push that we call thrust. At this point, you might be thinking, hang on a minute, isn't that just Newton's third law? For every action, there's an equal and opposite reaction. And you'd be absolutely correct. This is indeed a practical demonstration of Newton's third law. When those hot gases are expelled backwards with a force, the equal and opposite reaction is to push the airplane forward. But it's not just about raw power. The amount of thrust an airplane needs depends on a variety of factors: its weight, speed, and the altitude it's flying at. For instance, a jumbo jet on takeoff needs a great deal more thrust than a small propeller plane cruising at a low altitude. And so the dance of flight continues. The engine generates thrust, pushing the airplane forward, and the wings generate lift, pulling the airplane upward. These two forces, working in harmony, defy gravity and allow us to soar through the skies. With lift and thrust working together, an airplane can take to the skies. So, how do airplanes fly? In essence, it's a delicate dance of physics and engineering, a testament to human ingenuity. We've explored the principles of lift and thrust, which work together to propel these majestic machines into the skies. Lift, the upward force that opposes the weight of the plane, is created by the special shape of the wings, which alters air pressure. Then we have thrust, the forward force produced by the airplane's engines, pushing it through the air. It's a beautiful balance, isn't it? This balance between lift and thrust, weight and drag is what keeps an airplane aloft and moving forward. But let's not forget the role of control surfaces. These are the parts of the plane, like the ailerons, rudder and elevators, that help steer and stabilize the plane, allowing it to climb, descend and turn. The next time you see an airplane in the sky, you'll know the science that makes it possible.